Hello everyone. So we have the following differential equation question. So we have solved the following differential equation: y double prime minus 7y prime plus 12y equals t e to the t, with y of 0 equals 1, y prime of 0 equals 0, and we're going to be using Laplace transform. So please note that you could use other methods like undetermined coefficients, variation of parameters, etc. to solve this. Please note on notation where I have, highlighter right here, just notation here, Laplacian of lowercase f of t, the function f of t is going to be denoted by capital F of s. All right, so we're going to need a few Laplace transformations here. The Laplacian of a second derivative LF double prime of t, of a second derivative function, equals s squared capital F of s minus s lowercase f of 0, which is the function, minus lowercase f prime of 0, L f prime of t, so the Laplacian of the derivative is equal to s times capital F of s minus lowercase f of 0. And finally, the Laplacian of e to the c of t, f of t lowercase f, equals f of s minus c, and that f is the Laplacian of your function, but shifted by c units, okay? All right, so let's get started on this. So first thing, we're just going to take a Laplacian of both sides. That's this step. Now this other next step here is I'm using the linearity of the Laplacian. A Laplacian is a linear transformation. So if you add or subtract a bunch of functions and you take the Laplacian, it's equal to taking the Laplacian of each individually, like you see here. All right, and then I'm just going to apply some of the formulas that I used. So right here where I'm highlighting this, right here would be the Laplacian of y double prime. Oh, wait, here, this is the Laplacian of y prime. And right here is the Laplacian of y, all equal to, and then on this side, this is the Laplacian of t e to the t. Okay, so just be aware of that. Okay, now our goal when you're doing Laplace transforms, trying to solve a differential equation, you want to get y of s on one side, and yeah, capital Y of s here is equal to the Laplacian of y, or y of t. Sorry, I didn't mention that before. And yeah, all I did here on this step was took all the expressions that you see here, and I distributed 7, and then replaced f of 0 with 1 and f prime of 0 0, and this is what you get. So from this point, I go over here, and I get this right here. Sorry, let me erase this. And yeah, so all the stuff with a y of s was kept on the left. Everything that did not have a y of s on it was moved to the other side. And what I did on the right-hand side over here was I went ahead and got a common denominator, which came out to be the 1 over, oops, that should be s minus 1 squared, I'm sorry. My apologies. And yeah, so you get that, and then what I did, final step, was I moved the s squared minus 7s plus 12, and s squared minus 7s plus 12 can be factored as s minus 3 and s minus 4, or s minus 4, s minus 3. Okay. And our goal is to find the inverse Laplace now of y of s, and that would give me my function y of t that we're looking for our solution. Now, how do I do that? Well, notice how every term is factorable here, and I can use partial fractions decomposition. Sorry, the factors on the denominator. You can use partial fraction decomposition, which we did. And I won't go into that, but if you do all the work, this is what you would get for the coefficients, okay? So this is a good bulk of time that can be taken up by this. And yeah, so now I would just plug in all my coefficients back into my decomposition that I did over here. And I'm going to take the Laplace inverse of all of this, and the Laplace inverse is an invertible function. And yeah, I'm going to take the inverse Laplace of these, and this is what you get. So there's some definitely work involved. The other way you could have done this was with the convolution. Maybe you haven't gone into that, or maybe not, I don't know. But that's another option you have here instead of what we did. So, you know, in terms of like time, you might say that which way is faster. That's what a question a lot of people ask about these. I would say the faster method would be this over, let's say, like undetermined coefficients or variation of parameters, but it does get messy, okay? So just be aware of that, okay? Well, this isn't how this works out. Thank you for your time. Hope this helps.